Well, thank you very much. Now I have the challenge to see if I can meet the quality of a presentation of my students. So this is kind of I was not supposed to be here for this presentation, but my distinguished colleagues at both Aramco and the university could not attend because of his issue. And so the presentation really should have been by Dr. Assam. This is actually a very exciting project in my mind because parallels what you have heard earlier about Novus Crete. The emphasis here is obviously on seawater concrete, but in terms of the aggregate is really sea sand rather than desert sand. This is a project funded by Aramco, and again, very exciting in my mind to look at the use of these non-traditional materials in construction. So the presentation, the original presentation was a little close to 40 slides, so I cut it down a little bit. But I just want to give you the gist of the work that is underway, really, is not totally concluded. So the presentation breaks down into the typical items: introduction, objectives, materials and method, results, and then some conclusion, and then recommendations. I don't want to dwell on the introduction part. We have heard it, and we understand why this is relevant. But I want to make the pitch again for sea sand. This is not only an issue of the kingdom, but is an issue all over the world, and particularly in Southeast Asia. The interest in seawater concrete is really something that unites us. Clearly, if you are in the Chicago area, you probably have a very little interest in seawater, but as one of the presentation hinted today, there is brackish water, there is brine, there is many types of water that we consider outside the traditional potable or fresh water that is of great interest to us for this new sustainability paradigm that we have to satisfy. The objectives here are, again, very clear. We need to take a look at the seawater concrete, perhaps now with the addition of some of the supplementary cementitious materials. And in particular, in this case, we look at silica fume and natural pozzolan. This is, one of the possibilities. Obviously, one would wonder, why don't you use also different types of cements? And in particular, you will see later on type 5, or limestone cement. So there is I think you have to look at these items as a piece of the puzzle. The puzzle is very complex, and you have different types of binders, different types of supplementary cementitious materials that can be utilized, as in the previous presentation, to perhaps increase the, let's say, the performance of these materials. This is, in my mind, one of the most exciting slides that I would present today. And this gives you an idea of the different salinity of just the Gulf water. And what is very interesting, you heard this morning during the presentation of Ryan related to the impact of the desalination. One thing that he did not mention is after you desalinate seawater, you dump the brine back at sea. And look what it does to the salinity of the environment. This red dots have a salinity that is close to 45,000 parts per million. That is, 50% more of traditional, seawater. So this is really another issue that has an environmental impact of dramatic consequences. So it's not only just an issue of preserving natural resources, it's also an issue of not damaging with what you do. And obviously we need it. We need desalinated water. But sometimes if you desalinate water, you make fresh water to make concrete that you put back at sea, seems to be a little crazy, right? So anyhow, so this is kind of, I think it's a very interesting item. In this slide, you see the breakdown in terms of the components of this water, and then you can see the chloride ions being in the 40,000 parts per million. So extremely high in terms of their impact. This slide gives you an idea of what is the gradation of the sea sand that was used in this particular project versus the desert sand. So this, you can see the granulometry, the particle size distribution that is very similar in both cases. So there is really, from that perspective, not much of a difference. These slides give you an idea of the concrete mixtures that were selected for evaluation. Actually, the work that Dr. Cullen performed at King Fahd University was much broader than this. Actually, these are the 5 mixtures that were selected for the continuation of the project. There were a few slides before this one that gave you an indication on how this, let's say, selection was arrived at. If you look at the second row there is an indication of what are the constituents of this mix. Ordinary Portland cement, and then the natural pozzolan, only using 2 of the items, the silica fume, this limestone powder that was really intended, but then was replaced really with sand. And then you see, in this case, PW means potable water, not produced water. So PW for the potable, then the seawater, then the coarse aggregate was the same for all of them, whereas the aggregate, the small aggregate, the fine aggregate was, in the case of the conventional mix, regular sand, mine sand, and then the sea sand is for all the other mixes. Obviously, in the first column, you see the mix details, and the acronyms are pretty clear in terms of what they mean in terms of constituents. So the evaluation method for this project was kind of intense, and it went from looking at the characteristics of the concrete that you can see in the left-hand side of the slide, and it went also to the issue of the GFRP bars. Obviously, this morning is not so much related to the use of composite reinforcement, more to the mixture, the concrete. So the evaluation is really not presented. I only left a couple of slides there. But clearly, we have 2 types of concrete, plain concrete and reinforced concrete. So the majority of the work, obviously, is in the field of, if you disregard flat work, is really reinforced concrete. So the importance of having a reinforcement that is compatible with the mixture that is so rich in chlorides is very important. So I skipped, I'm not going to present here the characterization of the raw materials, but I'm going to spend a little time on the other items, the fresh property, which is a very, very important topic, hardened properties, and then finally some of the durability issue. We tend to disregard many times the fresh properties, but if you are a contractor, this is really how you make your living. And so this is something that we have to be cognizant of. And this is an area where there is a little bit of confusion, I think, in the literature. But in my mind, it's personal opinion, this is the part that we can impact very easily with the use of admixtures. So let's start looking at the fresh properties here. As you can see, the slides with the bars, there is really no difference between the benchmark and the other mixtures if we use the right, admixtures to correct the slump in terms of a single measure of workability. The slump retention is another issue. This is really important to see what is the finishability of your material. And again, also this can be corrected with the right use of admixtures. But you need to maintain good slump, meaning good workability, even after the critical item of the 1 hour and 30 minutes, as for example was indicated in the presentation about AC 574. Another item that is relevant to us, I'm going to go very rapid among this, and I don't think the point is so much looking at the numbers themselves, but have a sense that these materials are really part of what we can do today. This is not the future. This is today that can be done. Setting time also very relevant. As you can see here in the first 2 columns, there is a difference between the conventional and the mixture with seawater and sea sand. But at the end of the day, what is important is that we are within the ASTM standard C150. That is really a measurement of what is important to us. This gives you an idea of what is the compressive strength. So if you look at the diagram on the left, you can really see that in the case of the mixture that we study, there is definitely a difference between, let's say, what we call the conventional and then the mixture with seawater and sea sand. And one of the finding, and this is being investigated as we speak, is really a weakness at the interface between the aggregates and the cementitious paste. And this is more than the seawater, is really an issue probably due to the sea sand. And so this is kind of an item that is being investigated, and some of the SCM work that is being done now will shed some light on it. What is interesting is that the flexural strength has not really changed. So the ability of the material to perform under tensile stresses is apparently is not affected by this weakness at the interface. The durability, depending on how you measure it, there is many ways to do it, and the water absorption could be one of them. And as you can see here, there is not much difference between the mixtures. But if you look at the water penetration, the mixture that only has seawater and sea sand obviously is the one that is most affected by the water penetration. If we look at the comparison between another very important property that is fundamental, particularly for flat work, especially if you are not reinforcing it, slabs on ground where it seems that this material could have a great potential, is shrinkage. And drying shrinkage is one of the items that we need to look at. Definitely, there is more shrinkage in the case of the mixture that we said are non-conventional with respect to the conventional one. This is again is something that can be corrected with the proper use of admixtures or with a more, let's say, targeted use of the binder themselves with the substitution of some of the binders. The chloride diffusion, I think Osama spoke to that issue very effectively. Why is this important to us if we don't really have steel in it, right? But it's a very good indication, or as another indication, even though it was developed for steel, of the, let's say, quality and the durability of the concrete itself. And here you can see for yourself what are the differences between the two. I mean, it's kind of interesting to see what is the chloride profile. There is a very significant variation between the benchmark and the other four mixtures, but in terms of the chloride diffusion coefficient, basically they are all the same. One of the things that we tend to, let's say, not be cognizant of is the sulfate attack. And this is really something that we need to pay, in my opinion at least, quite a bit of attention. The sulfate attack not only comes from the presence of the sulfates in the seawater, but also if you have this concrete in contact with sulfate-contaminated soils. So this is something that we need to look at. And clearly, in the case of the, let's say, four mixture that we selected, there is not a very good performance in terms of sulfate attack. This is measured by weight loss in concrete, and then also this might be a result of some of the reduction in compressive strength after this measurement of sulfate attack. So I think this is something that needs to be corrected and looked at because it's certainly an issue, again, as I mentioned, due to the sulfate presence in the seawater itself, and then particularly if you have it in applications, slabs on ground with the sulfate-contaminated soils. Then looking at the GFRP, I kind of repeat what many colleagues have already mentioned, and this is not really the topic of today, but what is important to state is that even though we have demonstrated the durability of GFRP in particular, this is the focus of this project, under, let's say, conventional concrete mixtures, there is really no major difference if you add seawater or sea sand to the mixture. The only area where there could be some slight difference is in the bondability of the concrete. I mean, this is a property of the concrete, is not really related to the GFRP itself. So, you know, being cognizant of that, this might have an impact maybe on some of your parameters such as development length, but I don't think this is an issue. If you expose the bars to this more aggressive environment, if you wish, in terms of tensile strength, you don't see a difference. So some conclusions, because I know that I'm the only person that separates you from an important lunch, and in my case from a board meeting, so I cannot be late. The characteristics of the sand itself were, you know, not different from what we expected, and we don't have any major issue. But remember that not only in the case of seawater, but in the case of sea sand, or if you wish, desert sand, we need to be cognizant that these are regional issues. You cannot generalize and say all the sea sand is applicable, all the seawater is usable. So I think you have to be, as you look at sustainability, sustainability is also regional, okay? The fresh properties of concrete, I mentioned to you, the workability, but seems to show absolutely no problem. In this case, I think the right mixtures were used. In terms of microstructure, we have identified, and particularly the work that Dr. Kalim has done at the university, this interfacial transition zone seems to be the culprit of some of the degradation of strength that we have seen. Mechanical properties, this is kind of a repetition of the previous point. If you have an ITZ that is problematic, that obviously this translates in less strength. Interesting in the compressive strength rather than the flexural strength. In terms of the durability, I think the shrinkage can be easily corrected if you pay attention to what you put into the system. The part that is, in my mind, a little more concerning is the issue of the sulfate attack, for which we need to be cognizant of that and really make an effort to correct it. The performance of GFRP in you know, SWSS doesn't seem to create any problem. So I think we're very much excited about the project that Novus Crete will have shortly at NEOM, where some of these materials will be used. And then there is some recommendations. I would only invite you to read the very last one that is, I think, very important, that indicates that we still have to be cognizant of what we're doing in terms of generalization. And in particular, if this sulfur resistance is an issue, for example, the use of a type 5 cement could address the problem. So I'm only a presenter today, but I take responsibility because I'm part of the team, but really the credit for this incredible work goes to the colleagues in the kingdom. Thank you very much.
Thank you very much. We are a little bit out of time, but maybe one question. Go ahead.